historical argument called Auburn Paradox claims that an infinite number of stars in a limitless universe must result in infinite brightness in the sky. Our video does also claim that stars spread evenly in all directions in the limitless heavens with higher and higher population. So, will someday the heaven's brightness reaches infinity? Will we become blinded? Let's imagine the space to have been consisted of numerous spherical layers of equal thickness that all have the ASP as the center. Layer after layer, we call this hypothetical model an onion model. The universal homogeneous distribution of material in our observation would allow us to assume each layer being of the same density. So, before the first ever explosion in the universe, all these onion layers would have been of the same density and of the same material, which is hydrogen. If the materials have been absolutely evenly spread out, and when the material of the same layer simultaneously burns, we can expect that each unit area of this layer, or any layer, would release the same intensity of thermal energy. We use the symbol ρ to denote the intensity. When the burning is in process, calculations show that the total thermal energy the layers send to the ASP at any moment is 4 pi rho. This value stays the same for any layer of any radius, even at a point which is not at the center but within the onion layer. With such a model, if two spheres burn at the same time, the thermal energy intensity measured at any point within the two layers would be 8 pi rho. Then, 3 burning layers will increase the amount to 12 pi rho, so on and so forth. However, in reality, the universe does not have unlimited layers to be burning at the same time because of the following facts. First, each star's age of burning is limited. Second, it takes time for a star from a smaller layer to migrate to a larger layer and ignite a new star there. Third, the universe is infinite. All this comes together to prevent the Auburn Paradox from becoming true. During an epoch of the expansion of the illuminated portion of the universe always has a band of certain thickness that is expanding. On the side near the ASP, there are a majority of stars meeting their ultimate fate of dying. On the side furthest from the ASP, some stars just debut its infancy. Heat death, another historical topic concerning development of the universe, has long been happening locally in the vicinity of many dead stars. Heat death would first conquer areas near the ASP, trailing the step of star formation. However, heat death can never conquer the entire infinite universe. The universe has 74% of its visible material to be hydrogen within its illuminated portion. If someday human beings must start their life of space traveling, fuel, or source of thermos energy will never be their problem. Instead, what troubles their traveling may be the numerous black holes associated with no burning activity that are lurking all over in the universe. Heat and light, visible or invisible, are electromagnetic waves in nature. The so-called cosmic background noise is just a collective of the same kind of waves, but in random wavelengths, and is generated by the same sources that have generated heat and light. Since the ASP is statistically at the center of the illuminated portion of the universe, it is only reasonable that the total radiating energy intensity detected at the ASP should be isotropic. Indeed, it is how the background noise shows up in humans' observation. Is it an indication that the Earth may have been located at the ASP? In reality, radiating energy is all emitted from point sources other than from source of flat surface. When the radiating energy travels across the space, many of the energy bands cut across and superimpose each other, slicing the space into many zones of different intensity of such energy. Such zones can gradually drift. Different intensity of such radiating energy may potentially mean different temperature. So, our Earth may have to move through different temperature zones in space all the time. Although the time span of migration from one zone to the next may take years or even centuries. Will the different ambient temperature zones affect the Earth's climate to change from time to time? From the time the dinosaurs vanished, the galaxy has rotated only 1/4 turn about its center, but the Earth has had its climate changed many times. In case the traveling must have located the Earth in a zone of higher ambient temperatures today, what can we do about it?